Nuclear changes. This video is going to talk about different types and what's going on. So, nuclear changes. Are we talking about chemistry or are we talking about physics? In my mind, this is a physics thing, and let me explain to you why. When we talk about chemistry, chemistry is dealing with these little things that are whipping all over the place in an atom. Those are the electrons, those little tiny things. And what an atom does with another atom depends on its electrons. So electron studies are all about chemistry, or I should say chemistry is all about what electrons do. So when you're talking about the nucleus, what are you talking about? You're talking about this tiny little zone in the middle here where the protons and the neutrons are. How small? Yeah, really small. So here is a nucleus. I just went out and found one of these images. It doesn't really matter to us which atom it is, but this is a nucleus. And we're going to say the red things are protons and the blue things are neutrons. The protons are positive, the neutrons are neutral. They each have a mass of about 1 atomic mass unit. And we're going to say that this is an unstable nucleus because we want this nucleus to do some stuff so we can talk about it. So an unstable nucleus is a nucleus that's going to undergo some kind of change. It might do it on its own, or it could get hit by something else. It could get convinced into splitting or joining with other nuclei. But we're going to say that this unstable nucleus is going to make some changes. And when a nucleus undergoes a change, we call it radiation. Some kind of radiation is given off. And that's basically the main point of this video. So there's 3 types of radiation that I need to discuss. There is alpha, there is beta, and there is gamma radiation. So let's start with the first one. Let's start with alpha radiation. What happens if an unstable nucleus is going to give off a particle that is made of 2 of these and 2 of these? So we're going to get rid of 2 of the red things and 2 of the blue things. So we're going to wind up with something that looks like this. So we got 2 pluses and 2 neutrals. And I'm in a coloring mood here, so I'm going to color these. So there's my protons, and here are my neutrons. Okay, so this thing right here that I just drew, this thing is called an alpha particle. You could say that it's alpha radiation, and that would be fine. And relatively speaking, compared to the other ones, alpha particles are kind of big, kind of clunky, kind of slow. So your skin could stop them, or a piece of paper could stop them. And another word for this, alpha particle, please notice it has 2 protons. So this is basically a new nucleus. So this is kind of split into another nucleus. So this is actually, you could also call it a helium nucleus. So if this thing was flying around and it picked up a couple of electrons, you'd say, oh, there's a helium nucleus. And that's where a lot of our helium actually comes from. It comes from atoms underground that have undergone nuclear changes, and it gives off helium, or gives off alpha particles. And so that's one type of change. That's alpha radiation. Okay? So what happens to the atom? Is the atom still the same atom when this happens? Well, nuclear changes can have an effect on the atom's identity, on who they are. So let's just say that we were talking about, I went out and found this. Let's just say that we were talking about xenon. Let's say that this was a xenon nucleus. It probably wasn't because this one's pretty small, but we're just going to pretend that this nucleus is one of those. So this had 54 protons. It had 54 of the pluses. But now that it has lost this thing, it no longer has 54, it now has 52. So that means this is no longer xenon. It has become somebody else. So who is element number 52? That is tellurium. So when an atom gives off alpha radiation, it becomes a new atom, a new element. It becomes the element that is 2 lower. So xenon becomes tellurium. Now, what about the mass? Look at the mass here. The mass on this one, on xenon, is about 131. We're going to ignore the decimals because we're not talking about isotopes here, but if you give off a particle that weighs about 4, that means that tellurium should be about 4 units lighter, and it is. These decimals here, ignore those for now, but when a particle gives off, or when a nucleus gives off an alpha particle, it gets 4 units lighter. All right? Okay, the next one is beta radiation. And what is beta radiation? It's kind of interesting. One of these neutrons splits apart into two things. It splits apart into an electron, which is negative, and it splits apart into a proton, which is positive. So the electron, it goes whipping away, maybe to get caught by something else, and it's gone. And the proton is still in here. Okay, so the protons, it's once again, it is no longer element number 54. Instead of having 54 pluses, now it's got an extra one. So now we've got element number 55. And who is that? That is cesium. So the element goes from 54 to 55. So how much mass did the atom lose? It lost the mass of an electron. And how much is that? That's pretty much nothing. So when you give off beta radiation, this is called, when you give off an electron, it's called beta radiation. And basically the mass change is negligible. So we pretty much ignore it. Now, if anybody's watching, they're like, but look at these masses. They did change. This was 131 and this is 132. Well, remember, different atoms have different isotopes, different masses. So when we're talking about radiation, giving off a beta particle, or this little electron, doesn't change the mass. Okay? So giving off these electrons here, that's called beta radiation. Or you could call them beta particles. Or you could just call them electrons. But they're smaller and lighter than helium nuclei. They're smaller and lighter than alpha radiation. So they can penetrate through your skin and then go through, like, I don't know, maybe a book or something. So they're a little bit more dangerous. And the last one, the last type of radiation that I need to talk about is gamma radiation. Gamma radiation is the most dangerous of the three. It has the most energy. And what is it? Well, something inside the nucleus reorganizes. It shuffles around. It goes to a lower energy state. So when this happens, the nucleus gets rid of that energy in the form of electromagnetic radiation. And it's very, very short wave, and we call it gamma rays. I've heard people say gamma particles or gamma waves, but the key is that you know this word, gamma. And one thing that's nice about gamma radiation, at least from a student standpoint, is that when you give off gamma radiation, none of this changes. Your protons are still the same, so you're still the same element. So if xenon gives off gamma radiation, it's still xenon.